students, so we have to start our numerical part of chapter 2nd, that name is machines. Before proceeding in numerical part, we have to keep in our mind some formulas of chapter 2nd. Okay, there are like this. Number 1 is, that is moment of force, like effort into effort arm, okay, is equals to load into load arm. Okay, first formula of chapter 2nd. Second one is mechanical advantage. Okay, mechanical advantage given by a machine, that is equals to load upon effort. Okay, load, that is work done by machine, and effort that we applied on a machine. Number third, that is velocity ratio. Velocity ratio is distance traveled by effort and distance traveled by load. Okay. Number 4 formula that we have to keep in mind, it is efficiency, that we denote with eta, and it is equals to mechanical advantage upon velocity ratio. And there is one more thing that we have to keep in our mind, capital L, that we are saying that a load. Okay, it is a total load. Okay, total load, in which there is a small l plus x. Okay, and small l is the useful load. Okay, and x is the load due to resistance of a machine. Okay, so total load we will consider here as capital L. So keep in mind all of these formulas before proceeding in numerical part. So let's start with the first numerical of your book, that name is Goyal brothers. Okay, yes. So here is given question number 1 from the book Goyal brother, page number 39. In this question is given, in operating a water pump, okay, that is the hand pump, alright, a resistance of 480 Newton is overcome by an effort 72 Newtons. Okay, resistance means the load. Okay, resistance means the load, that is 480 Newtons, and it is overcome by the effort है 72 Newton. Okay, if the distance of the fulcrum from the point where the resistance acts is 0.m meter. Okay, यहाँ पर क्या दिया है आपको, फलक्रम की डिस्टेंस दी है. ठीक है, आपको लोड का डिस्टेंस दिया है फ्रॉम द फलक्रम, दैट इज लोड आर्म. ओके, it is given 0.2 meter. Okay, you have to find the distance from the fulcrum where the effort is applied. You have to identify the effort arm. Effort arm you have to identify. Okay, and you have given the load, that is 480 newtons, and effort is given, that is 72 newton. So we can calculate, it is very easy. We only have to keep the values. Okay, effort and effort arm is equal to the load and load arm. Okay, and we have to calculate load effort arm. So what we have to do, 72 into effort arm and load, that is 480 into 0.2 meter. Okay, so we will get effort arm by calculating these values of given. Okay, so here we can calculate like this, and the answer we will get easily by simplify this. So here is the question number 2, that is given a uniform plank of a seesaw. Okay, and there is a one boy of 40 kgf is sitting at 1.5 meter from the one end of a seesaw. Okay, and here is the 5 meter, that is the complete length of seesaw, and we have to allow a girl to sit on this seesaw to make it balance. Okay, so first one that we have to calculate the load arm of first one case, okay, for the boy. So the load arm, that is, we can calculate. Here is the at position where he was sitting on seesaw. So we have to identify the length from here to the fulcrum, okay, that will be considered as a load arm. So what we have to do, 5 meter is is the complete length and the fulcrum is at the middle. So here will be 2.5 and 2.5. It is the equal distance from the fulcrum to the one end and to the another end. So what we have to identify, first the load arm. We can simply divide. That will be 1 meter. Okay, 1 meter is the load arm for the 40 kg boy. So what we have to do, we simply have to put the values of every given things. Okay, like this, 40 into 1, okay, and it was 25, and the effort arm, it will be like this, that is 40 into 1 upon 25. So what we will get, 1.6 something na meter. Okay, it will be, it's ये आपका यहाँ से यहाँ आया है जो कि आपका कंप्लीट है, लेकिन आपको क्या करना है, कहाँ पर बैठाना है जिससे कि ये आपका सीसो बैलेंस हो. तो व्हाट वी विल डू, वी विल सिंपली डिवाइड 1.5 1.6 and here we will get the answer, that is 0.9 meter. It is the complete answer. Okay, now the next one. Here is it given a diagram that we have to understand first before solving the numerical. There is a walnut, okay, and here is the fulcrum. All right, walnut is considered as a load. All right, and here is the effort that we have to apply on this to press this walnut, okay, or to break this walnut, that is considered as a load or resistance. And effort that we are applying, it is 30 Newton. All right, we can clearly see that the distance from the fulcrum to the load, it is 5 centimeter. And in your book there is given the distance from the load to the effort, it is 20 centimeter. Okay, so we can write the first thing, that is the load arm. Okay, load arm, that is 5 centimeter. Okay, all right, and it is the example of second class of lever. Okay, that was, we have learned earlier that the FLE, okay, flea. We have learned earlier that in this, the first class, second class, it is the third class of lever. In first, fulcrum is in between the effort and load, and in second class of lever, the load is between the fulcrum and effort. And here it is the third class of lever. In this, the effort is in between the fulcrum and load. So this example is considered as the second class of lever, in which the load is at between the fulcrum and effort. Okay, so the total length, that is the load length or load arm, it is 5 centimeter, but the effort arm, okay, effort arm, it is the perpendicular distance from the fulcrum to the effort. Okay, fulcrum to the effort, that will be the total length. Okay, total length of the effort arm. So effort arm will be 20 plus 5. Okay, it will be 20 plus 5 and it will be 25 centimeter. Okay, solve. So we have to simply calculate the load. So effort into effort arm is equals to the load into load arm. So what we have to calculate, the load, put the values of everything, that is the effort arm, it is the 25 meter, and load that we have to calculate, and it is 5 centimeter. So by keeping the values, we will simply get the answer of load, that is 150 Newton. Okay, I hope you all understand this practice problem number 3rd, and the question number 1. A machine displays a load of 125 kg through a distance 0.30 meter, that is considered as a load arm. Okay, acts through and when an effort of 12.5 kgf, that is effort, okay, it is an effort arm that is 4 meter. So we have to calculate the velocity ratio, mechanical advantage and efficiency of that machine. So the first one, that is the velocity ratio, okay, that is the distance traveled by effort and the distance covered by the load. So we can simply have to put the values of distances. That is the effort, that is 4 meter upon 0.30 meter. So what we will get? We will get simply the answer. It is like, and we will get 13.33 something answer. Okay. And second part, that is the mechanical advantage. It is load upon effort. Load upon effort. Load is given here 125 and effort is 12.5. Okay. So what we will get? We will get mechanical advantage is like 10. Okay. Mechanical advantage is 10. And what will be the efficiency here? Efficiency, it is equals to magnetic mechanical advantage upon velocity ratio, and we will get the answer like this, n upon here 13.33. When we calculate it, we will get the correct answer, that is the 75% efficiency of that machine. Question number 5 on page number 39. Okay, a resistance of 500 Newton is overcome by a machine of velocity ratio 5 and efficiency 80%. Okay, we have to find the mechanical advantage and effort required to overcome the resistance. Resistance means the load. Okay, so we have to find out the mechanical advantage with the help of velocity ratio and efficiency first, and then we have to identify the effort. So first one, that we have to, what we are having the formula of efficiency, that is the mechanical advantage upon velocity ratio. Okay, so efficiency is given 80%. Okay, 80%, we can write 80% is like this. Okay, and here is the mechanical advantage that we have to find out, and the velocity ratio is 5. So simply mechanical advantage, it will be like upon 5 into 80, it will be 5 into 80 upon 100. Okay, I'm getting confused. Okay, so here will be 4. Mechanical advantage is 4. Okay, and now the efforts. How we can identify the effort? We know the mechanical advantage is equal to the load upon effort, and we are having the load here. We are having the load, that is the 500 Newton. So mechanical advantage, as we get 4 is equals to the 500 upon effort. So the effort will be 4. So we can, by calculating it, we will get the effort, that is here. The effort is 125 Newton. Okay, or 125 Newton. Yes, it is the answer of this question. So it was the efficiency, it was the mechanical advantage here, and here it is the effort. Okay, thank you so much, students.